This is nuclear stability by Lab Group 3. Most atoms we encounter have stable nuclei, or in other words, are not radioactive. This is a good thing, because radioactive atoms can have very serious and harmful effects. You might ask yourself, why are some atoms stable and some are not? This all lies in two different forces. The first is the electrical force, and the second is the strong nuclear force. Electrical force works like two magnets. When the poles are opposite, the magnets attract. When the same poles are facing each other, the magnets repel from each other. Similarly, atoms with the same charge, like a group of protons, repel from each other. The second force is the strong nuclear force. This is not a force that we see in our everyday lives, like one that would act on two humans. This is because the strong nuclear force is only significant between subatomic particles that are extremely close. The strong nuclear force is the force that brings all subatomic particles together. Both forces act on protons. The electrical force repels them from each other because they all have the same charge. The strong nuclear force attracts them together. For neutrons, the electrical force has no impact on them, since they have no charge. The strong nuclear force attracts them. This is what makes neutrons like the glue of a nucleus. The ratio of protons to neutrons in the nucleus of an atom follows a pattern that corresponds with the periodic table. For elements 1 through 20, a stable atom will have about 1 neutron for every proton. Further down the periodic table, more neutrons are needed to compensate for the positive charges of the protons. This ratio could be something like 1 to 1.5. Beyond element number 83, no amount of neutrons will be able to compensate for the amount of protons. This is why all elements after 83 are radioactive. In this diagram of the ratio pattern, the orange line shows where the protons and neutrons are equal. As you can see, the more protons an atom has, the more neutrons are needed to balance it out. As we know, if there aren't enough neutrons in the nucleus of an atom, the electrical force will pull the nucleus apart. On the other hand, having too many neutrons in the nucleus of an atom makes the neutrons more likely to emit beta radiation. In general, if an isotope is much heavier than the typical isotope of an atom, or it's much lighter, it's typically radioactive. The most stable atoms are very close to equal to the typical isotope of a particular element. This is nuclear stability.